Filtering select statements using the where clause. Here is the syntax for the select statement with the where clause highlighted. Note, all we do is we say where something such as column or expression, a comparison condition such as column equals, and then another column or expression represented by the 3 dots. So we can say where something equals something. The conditional comparisons can be a multitude of different things. We'll get onto those in a minute. We also have logical operators where we can say where something equals something, and something equals something, and something, etc., etc. Or and not will apply as well. Here's a simple example where clause where we said select from where parent ID is not null and the parent ID is equal to the category ID. We have seen this select statement before. Logical operators. And has higher precedence than or. So anything after the or should be parenthesized in much the same way that a minus or plus mathematical operator is parenthesized in order to take precedence over, for instance, multiplication or division. Multiplication or division have higher precedence than plus or minus. That means that they're executed first. So therefore, and is executed before or. You've got to make sure you get the meaning right. Conditional comparisons. All I'm going to do is list them out and briefly explain them. Once again, we'll get on to examples in a minute. Expression equals expression. In other words, x is equal to y or x is not equal to y. Note that the exclamation mark implies negative and is optional. Expression like. You use an expression to say like a pattern match. Expression in expression. Something is in a set or something is not in a set. Expression exists or not exists. That means that something exists in a set or it does not exist in a set. Expression is between something and something. A value is between two different values. It's a range check. Any sum and all apply to grouping functional expressions. We will get onto that with the group by clause later on. Note, every single one of these comparison conditions can have a subquery substituted for this phrase expr, in other words, expression. The only one this does not apply to is the left-hand side of the exists comparison. Let's use the where clause. Let's use the where clause in its simplest manner without including details on logical operators or the different conditional comparisons yet. We will get to those. Let's first of all go and select everything from the category table. And there we have 34 rows selected. Now let's apply a where clause. What we're doing is we're filtering out everything that does not have category ID 1. So we're saying where category ID is equal to 1. We find a single record with the category ID value equal to 1. Now let's change the where clause a little. We're going to select every record from category where the parent ID is null. We have 4 records. Let's verify that. What we've done is we've displayed the parent ID on the screen showing that all parent ID values are null. Let's look at an example that we've had some practice with in the past. This shows all show records with a null show. Now let's look at using logical operators. In the where clause you can apply multiple conditions such as x equals y and x equals z and x equals a, or etc., etc., using logical operators. You break up different conditions using these logical operators, and you can have something and something, something, or a combination thereof, and you can also use not to negate the logical operator. Once again, remember what I said about precedence, where the AND logical operator takes precedence over the OR logical operator. What this means is that AND is executed before OR, unless you parenthesize. Anything in brackets will be executed first. So, let's go and take a look at some examples using logical operators. First of all, let's select everything from the category table. We get 34 rows. Now, let's once again select everything from the category table where the category ID is 1. So we're filtering out everything but the first row. And once again, we will select everything from category where the parent ID is null, and we have 4 rows. Now what we're going to do is we're going to select everything from the category table where the category ID is 1 and the parent ID is null. This is not really necessary, but it demonstrates what we can do. We could get the same result by simply specifying category ID equal to 1. But we want to show that we can find a category record specifying both of these conditions. Now let's use the OR condition and specify the category ID as being 1 or the parent ID as being null. We actually get the same as parent ID is null, but you can see the point. Now let's try another one. Let's specify that the category ID can be 1 or 2, and therefore I find the first 2 records. Now let's do something else and specify category ID as being 1 and 2. This will give me a no rows selected response. Why? Because the category ID cannot be both 1 and 2 at the same time. This demonstrates the difference between OR and AND in a very simple fashion. Now let's go and look at precedence between AND and OR. This is how we execute precedence. All this is saying is that I want to select all the category rows where the parent ID is null and either of these two is true. Because of the parentheses, what will happen is that the where clause will assess this statement first. So it will find category ID 1 or 2, and then after that it will assess the logical AND operator. So it will say select all records where category ID is 1 or category ID is 2, then select any records out of these where the parent ID is null as well. An easier way to show this example is to find a category ID that definitely doesn't have a null parent. So what we have is we specify the category can be one of these two, and then we apply the parent is null condition as well on top of that. Let's try to explain precedence in a step-by-step process. First of all, what I want to do is I'm going to select the show ID and show date columns from the show table where the show date is null and the show date is not null. I find no rows because there are no rows which are both null and not null at the same time. That is, a null value in the show date and a not null value. It doesn't exist. The rows are either null or they're not null, they're not both. Now we can show all working, where it says go and select all records which are null, all records which are not null. In other words, we will select all the records, 147 rows. That is exactly the same as simply selecting all the rows from the file, as in this query. Let's go one small step further with this. And now I've got 147 records. Let's execute this query. What do I get? I get 141 records. I also get every record in the show table that does not have a null show date. Once again, let's go back to the previous query. and we see we've got 4 records at the end and a few up here somewhere with null show dates. There's 1 or 2 there. I see 1 there, and there's another one. There's -6, 147, -141 is 6 records. What's happened here? I've said go and select every row where the show ID is less than 10 that has a null show date. We know there aren't any from the data, so theoretically that selects no data. This OR condition applied after the AND, because OR has lower precedence than AND, will simply say, okay, regardless of what I've got there, I want to select every show date that is not null. Effectively what's happening with this piece of this where clause is absolutely nothing. It's having no effect because the precedence is not set in the right place. The correct way to do this query, or a correct way, is to parenthesize the second part such that it's executed before this part. So the parenthesized part is executed before the AND logical operator. And the final result we get for this query is this, which is 9 rows, which is correct. Now let's take a look at using conditional comparisons in examples. Once again, here's the where clause. Each comparison in the where clause is represented by something such as column or expression, conditional comparison, and another column or expression. In other words, where x equals y, where show ID equals 1, etc., etc. Don't forget the logical operators and the precedents. Conditional comparisons. We've already gone through them, but let's go through them once again. We can say something equals or not equals something, something is like something, something is in or not in, something exists, something is between a range of values, plus the group functions. We will leave the group any, some, all functions for the moment. Let's do some examples with conditional comparisons. What I'm going to do now is I'm actually going to make some small changes to the conditional comparisons. I initially set them up so they could be easily understood. There are a few small changes I need to do in order to be more precise now. First of all, equality. Expression equals or not equals expression can be expanded to include greater than, less than, greater than or equal, and less than or equal. Let's do some examples with this. First of all, let's go and select everything from the category table again. I get 34 rows. Now let's go and select, once again, the category table, select all rows where the category ID is 1. I get a single record. Now I'm going to select everything from the category table which is not 1. So I find every row, 33 rows, but the first row, category ID 1, is not there. Now I'm going to go and select everything from the category where the category ID is less than 10. I find categories 1 to 9. Following that, I'm going to do everything where the category ID is greater than or equal to 30. I find the last 5 rows, which is 30 to 34. The like comparison condition. Like is used to pattern match from left to right. Let's take a look at some examples. First of all, let's go and select everything from the act table where the name of the act includes the lowercase letter a. What this pattern match is doing here is it's finding any string plus the letter a in any string. So anywhere within the string that contains the lowercase a will be a valid record. So let's run this query, and as you can see we have lots of names with a's in them. A is a very commonly used letter. Now let's be a little more selective and find every name in the act table which begins with an uppercase letter A, a capital A, and we find a single record, Arena Cross. Now let's expand that a little and find everything beginning with an A or a B, and we find 3 records, 1, 2, 3. Now let's change this a little and change the OR to an AND. Once again, back to logical operators. This finds nothing because I cannot have a name being A and B. It can only be A or B. A and B implies that a name is 2 different things, so therefore we find no rows. The next example. This one is saying where the name is like A or the name is like B, so it finds both A's and B's, and it specifies that the act must be less than or equal to 10. Notice that 36 is not less than or equal to 10. That's because we haven't parenthesized the OR part of the where clause. We haven't set the precedence properly. So what we'll do is we'll run this query again using like, and we'll make sure that we put the brackets in this time and we get the correct result. We've got name is like A or B and act ID is less than or equal to 10. Remember, Arena Cross had an act ID of 36, which is out of range. The last example I want to do is a negative. It's basically the opposite of the previous query, where we're saying select like A or B and not less than or equal to 10. In other words, we're finding everything that is greater than 10. We could have done this query in a simpler fashion by simply saying and act ID is greater than 10, and we would have found 36 as well. That just demonstrates the use of a negated logical operator with the like comparison condition. What's next? The in condition. What in is used for is assessing whether whatever is on the left side is in as a set comparison condition. Generally, in is used to check against fixed literal values. You can use in to check against a subquery, as in selecting data from a table, but that can be inefficient if the number of rows retrieved from the subquery is a large number of rows or the data is not static. Let's take a look at in. What do we have here? I'm going to select everything from the act table, just looking at the act ID, where the act ID is in 1, 2, 3, 4, 5. And we can see that it's selected act IDs 1 to 5. Let's do the example the opposite way around and find everything that is not in that set. We find 48 rows, which is the total 53 less 48, minus the first 5 rows, which we found the first time. Exists. Initially, I set exists to say that it was expression, exists, expression. This was to avoid a certain amount of confusion. And also note that a subquery cannot appear on the left. Now, exists is not quite that simple. What exists actually looks like syntactically is this. There is no expression or any kind of thing on the left of an exists conditional comparison. Let's look at some examples to explain this more clearly. All it's saying is that something where exists or not exists, subquery, expression, etc. And it should be noted that this expression on the right has to contain a subquery. So the exact syntax for exists actually looks like this. Let's look at some examples using exists. What we're doing here is we're finding the act ID from the act table where it exists in this subquery. That's everything, because this always exists. It's always equal to x, but since it is not a null or a false value, it exists, period. Let's take a look at the second example. Here I'm actually using a subquery. What I'm doing here is I'm going to take everything in the act table where it exists in the subquery. Now, we haven't got to subqueries yet, so we don't want to go too far with this. But what we're doing is we're selecting again the act ID from the same table, and we're saying where the act ID is less than 10 and the act ID is equal to the act ID in the calling query. So we're actually joining it with a subquery. All we're going to get here is go and find everything in the act table where it exists in the subquery. The subquery is actually act IDs 1 to 10. So it's taking the act IDs in this query and it's saying it exists in that subquery which contains 1 to 10, and thus, well, it's actually 1 to 9 because it's less than 10, so therefore it's 1 to 10. Let's take an example of another exists query. And here we're actually going to go and look in a separate table. What we find here is act IDs 2 and 3. Why? Because this subquery finds all the supporting act IDs. Supporting act IDs distinct values are only 2 or 3. So if we were to execute this and say distinct, remember distinct finds unique values, and I'm simply going to copy and paste this, I find 2 or 3. The point to note is that I'd run a subquery and found 2 values, 2 and 3. I then used the where clause in the subquery to link to the calling query alias act ID. This is a complicated type of subquery called a correlated subquery. I don't really want to go too far with this at this point in time because that's dealt with later. This is what we're trying to look at, is basically the exists condition. All I'm really trying to get across is that one says where exists and then in a subquery. The next one is expression between expression and expression. This one is very easy. It's just a range check. So I'm just going to take an example and paste it in, and we get 1 to 10. We could do the same thing by doing something like this. It will have the same effect using greater than or equals and less than or equals. And we get on to any sum and all, which are effectively grouping expressions, and we won't cover those now.